3D constructions, you can fake it. So you can do like 2D constructive geometry and make it look like 3D, but you cannot easily rotate something in a 3D coordinate system, for example. Or it's difficult to, it's probably almost impossible to make a graph plot like this up here. So you have some surface. And we will just have this as an additional new view. So it will not be a separate software, but GeoGebra 3D will be integrated into GeoGebra as a new view, like there is the 2D graphics view we have right now. And then you can also display a 3D graphics view if you'd like to, and they will be connected. So the idea is also that all of these things will be connected. That you can do something in 3D and look at the plane and display this plane in the 2D view and things like that. The 3D is not that fast, so we will probably not be able to include it next year, but probably in 2 years I think it will be ready to be released. But there are, for all of these things, there are better versions out there. So if you are interested in the forum, in the user forum, you can always just ask, I want to become a beta tester, and then you will get a magic email from somebody, and you will be invited as a beta tester, and you can get access to those things. The spreadsheet, you have probably seen the spreadsheet in GeoGebra 3T, the 3.2, which is already available. But we want to improve the spreadsheet just to make it easier to create things like histograms and simple statistics, so there will be wizards. You can just click on a special tool to get a histogram. And there will also be other things like you see on this left picture. You can include pictures in the spreadsheet, you can have buttons and have a little command behind the button. If you press a button, you create some random numbers, or I don't know, you move around some pictures. So you can do lots of advanced things for those people who really like to create materials using GeoGebra. And this is being done by a colleague from the US. So George Sturr is a teacher at a college, so he's teaching students from about 18 to 20 years, and he's teaching statistics himself. So the reason why he got involved in GeoGebra as a programmer was that he wanted to use GeoGebra for his own teaching. And this is very typical for our developers and for everything that's happening with GeoGebra. It's always somebody who wants some feature for themselves, for their own purposes. So they're really interested in getting it in, and also they know exactly what they need. So it's not us that we say, oh, maybe we should do something about statistics. We don't really know what people need, so let's just put something together. But it's really from the other way around. There's somebody coming with a specific need, that's what they want, and they get it in there. Another project that I'm working on is the CAS view. So CAS stands for Computer Algebra System. So there already is a computer algebra system in GeoGebra where you can do some kind of symbolic computations, meaning you can work with fractions and you can solve equations and you can do stepwise manipulations of expressions, substitution and these kind of things, what you would do with derive or maxima or mathematica. So we want to open it up to the user and also connect it with the rest of GeoGebra, so that you can use, let's say you do a conic section, and then you use this equation, put it into the CAS, and then make some computation with your equation, so to be able to interact with that. And the locus line equation is one example, where you could get an equation from your construction and then do something with it. And the goal is to make it easier than the typical computer algebra systems, so that we can use it with students from an earlier age on, so maybe 12 or 13 years, when you really start to introduce equations and algebra in schools, that from that time on we can use such a system. So what we really do is we create a syntax, an interface that is hopefully a little bit easier to use than Maxima, for example. And in the background we use powerful computer algebra systems. So there will be Maxima used under the hood in GeoGebra, but the users, so you will not see that there is Maxima used. It's just inside of GeoGebra. And we just translate the GeoGebra way of doing things to Maxima. Okay? So that's also one of the nice things of open source. We can reuse this very powerful package at Maxima. We don't have to reinvent the wheel and create just another computer algebra system, which we could, because it's a task for 20, 30 years, so it's I will be retired. No, I will not be retired. So it would take too long. So it's very nice just to take this package and build on it. Something else, Zsolt mentioned the wiki, the GeoGebra wiki with lots of objects in there, so those dynamic online web pages. The problem now is we have too many, which is nice, but the problem is it's difficult to navigate and difficult to find anything. How do you know which workshop is good, of good quality, not so good quality? How do you know about the experiences of people? So what we would like to do is just have a simple way to upload a file from GeoGebra to a web page. So in GeoGebra there will be a button, Share, and you click the Share button and it goes on our web server, and then you will have this as an applet online. And then other people, they can rate, like on YouTube. You can say, oh, I like this very much, I give it 5 stars. And you can also comment, so you can say, I tried it in my classroom, there was a little problem here, so be careful about this aspect. So the idea is to make this very simple and have a way to make it easier to share materials and to find what is actually useful for yourself. This is also done by a student. So it's also done by one of our GSOC students. His name is Florian and he's from Germany. Another project that is closely related with the GeoGebra 2 project, with this online database of applets. At the moment, GeoGebra requires Java to run. So you can run GeoGebra and GeoGebra applets on your computers, on a Windows computer, on a Mac like this, if you have Java installed. So Java is typically installed on all of the machines, so you don't really need to know what it is, it's just there, it works. But on the new devices, on the new smartphones like the iPhone or Android phones, you will not have standard Java. So it simply means GeoGebra does not work on these devices. It doesn't work on the iPhone, it doesn't work on the Google phones, it doesn't work on Nokia phones. Okay, so we're thinking about what shall we do about that. You know, we would like GeoGebra applets to be able to be used by students also in such an environment where they have it available all of the time. And what we have done is we have started a project where we kind of, so it really means you have to start from scratch. So you have to redo GeoGebra. But this would have been a too big task. So we managed to find a way to take the old Java GeoGebra and convert it, at least parts of it, automatically into something that will run on these mobile devices. And for those who are more technically inclined, what we're using is we're using Java to JavaScript conversion. So what is happening is that these new applets, they will work in every web browser without the need of Java. And all of these cell phones, all of these smartphones, they have web browsers. So you can just watch the GeoGebra applets in the web browser on these devices. And it doesn't matter if it's an iPhone, an Android, a Nokia phone, whatever. And also like on the new tablet devices, like the iPad, or there are Android tablets coming out. So lots of devices that we want to support. And we have a pretty nice prototype already. So we have these applets working. Also with touch support on the iPad, so you can drag things around on the iPhone for simple constructions already. So by next year, we hope to have most of the GeoGebra constructions supported. So the goal is really that all of our applets, everything that you export from GeoGebra into a web page, can use this new kinds of mobile applets. Because the advantage is you don't need Java, so they will work everywhere. Yeah, and another thing, so we don't forget about other platforms either. For example, the One Laptop Per Child project. So we have put together a package so you can install and run GeoGebra on the One Laptop Per Child computers. For example, in Uruguay, they have bought, I don't know how many